Hello Gophers and welcome back to part 8 of Introduction to Go. In this video we'll be learning about conditional statements. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new updates.
Topics that I'll be covering today in this video are if and else conditional block, comparison operators that are available in Go, logical operators available in Go, and in the end we'll also discuss some examples with switch statement. Now let's start by understanding if and else logical or conditional block. If and else conditional block is normally used when you want to analyze a particular variable or particular set of variables and perform some statements according to your condition. Let's say I have an example where I say if I have a variable with name age and I want to see if age is is greater than and equal to 18, then user is allowed to vote, otherwise user is not allowed to vote. Now here I have used if and I have used a comparative operator which says greater than and equal to, which means if age is equal to 18, then also this condition stands true and my code workflow will enter this block of code and will not execute this block of code. Now there might be some situations where you want to skip the else part. You are not concerned about an else logic. You don't have any else part for that. So you can definitely go ahead and skip that. But the point to be noted over here is the else block has to start with the ending of the if curly bracket. You cannot have this else in the next line because this is not allowed in Go, as it is allowed in other programming language as Java or C Sharp. This is not allowed in Go. In Go, you are also not allowed to start the curly bracket of conditional block in the next line. You have to mention the starting of the curly brackets in the same line where you have mentioned the condition. So Go is very specific about the syntaxes and uh, align fields. So you need to take care of these things. Now, sometimes you might also get into a condition where you want to analyze more than one variable or more than one condition. For example, I want to see uh, for an military examination, I want to check if the gender is female, then the minimum required height would be 5 feet. And if the gender is male, then minimum required height is 5.5. So let's do this with this example. I have example female is false. So I'll have declared a variable with name female. So if this is true, then this means that the candidate is female. If this is false, that means candidate is male. And height is supposed to be 5.2. And now I am getting into condition where I say female double equal to true and height greater than 5.0. So this condition says that if the candidate is female and height is greater than 5, then the candidate is eligible. But what happens if this is not true? That means either of these condition is true, is false, then we'll get into the else block. So let's say if the candidate is female, but the height is less than or equal to 5.5, we will get into else block. But in else, I want only one condition where I want to analyze if the candidate is male. So I'll say else if female double equal to false and height should be greater than 5.5, then the candidate is eligible. So these are two conditions that I have mentioned, but the end result that is there is same. So I can club these two with an OR conditional operator as well. So if I go ahead and place this over here with the curly bracket to be very clear and mention the compiler to be executing these two conditions together, result together, and then this result together, and then doing an OR, not eligible. Now let's try to run this. Go run condition.go. Now if you see, user is allowed to vote, and I had female is false, that means this candidate was male. And okay, I didn't remove the else condition. Now let's run this. It says not eligible. So let's see if it was truly correct output. So I have said that the candidate was male because female is false and height was 5.2. That means definitely this condition is in together false. And if I go to this condition where female part is true and height part says it as false, so this is also false and this is also false. That means we'll get into an else block. Now if I increase the height to 5.6 and then try to run this, it says eligible. Or if I say this to true and this to 5.1, let's see, again eligible. So this is if and else. Now if you want to have multiple if and else condition that we have just saw, that we can have an if condition clubbed over here also. For that I have given one more example where I want to analyze if a number falls between some range. So here my example says that if a is greater than or equal to 5, or a is between 3 and 5, or a is less than 3. This can be a perfect example for your grading system as well. Okay, so now let's see what the result would be. So a is greater than 5 definitely. Yes, so we'll get this output. Now let's try and run this program. It says number is greater than or equal to 5. That means it is executing this if. Now if I reduce this to, let's say, 4 and now try and run this, the number is greater than or equal to 3 and less than 5, because I have considered equal to 5 over here. So that means if the number is less than 5 only, then only it will get into the lower else block. And in lower else block, it will start analyzing with this block first. And here it saw that it was true. That means it fall into the second ladder of if and else, did not go into the last part. Now if I go beyond 3 or equal to 3, let's see, for equal to 3 the result should be same. So it says same, the greater than equal to 3 or less than 5. Now let's go to 2, so it should go into else block. So this else is also not very mandatory. I can definitely go ahead and remove this from the if and else ladder also. Will not get any output for this block of code, because now it was neither in this condition nor in this condition, so it did nothing. So that's about if and else. Now let's understand what kind of logical operator and conditional operators are there in Go. For comparison, we have these six comparison operator where the first one is only greater than. So if I go here and I can check this. If I say if age is greater than 18, then only the user is eligible. That means if user is at least 19, then only he or she is eligible to vote. Now if you see, user is allowed to vote. So equal to 8, if it is age is equal to 18, then also the condition becomes false. So this is one operator. Then we have a less than operator, which is again same, where we just reverse this thing and say if age is less than 18. So in that condition, we'll say not allowed to vote, and else part would be allowed to vote. Now let's run this. User is allowed to vote because it was equal to 18, so it failed this condition, went into else part. Then we have a greater than equal to operator, which we just saw. Then again less than equal to. Double equal to is a comparison where we compare both values to be exactly equal, as we did in female equal to true. Then we have a not equal to operator, which means that if one part of value, one side of the operator is not equal to other part, then the condition becomes true. So let's discuss that also with an example. Let's say I have a variable g which has value 10, and if sorry g is not equal to 10, fmt dot println g not equal to 10. So if I go ahead and run this, so it was equal to 10, it did not, that is why it did not print anything. Now if I say it as 11, or if I go with 9, condition becomes true because that is not equal to, so g is not equal to 10. So these are six comparison operators that are available to us. Now let's see what are logical operators that are present. We have two logical operators that we can use. Those are double and two pipes. These two pipes stand for an OR operation. OR operation that we have just tried and tested over here. So this is OR, where it says either this part or this part. Any one of these if is true, it will get into the if block. Otherwise, it will go ahead and search for the corresponding else block for it. Now, we'll also understand how we can use assignment in if block, if and else statement as well. One more thing that we need to keep in mind in Go, that is, we cannot skip the starting and ending of the curly bracket in a if and else code block. If we have a single line of logic in those blocks, because that might be uh, valid in other programming languages like like C sharp or Java, but in Go you need to apply the curly bracket starting and ending even if you have one liner statement or one liner code block in the conditions. So this you need to keep in mind. This is not allowed in Go. Another thing that we are now discussing is how we can use the initiation statement in the if block. This is new. This is something that is not available in most of the higher end languages, where you can declare a variable in starting of your if block, and you can use that variable in the if block. So if I see fmt dot parent line in comma f. Now let's see if a which is equal to 2 is less than f, That means this would be true, definitely. Now let's run this. If I see init 11, so this f is just in the scope of if. Now if I try to access this f outside the if block, I'll not have access to this if block. If I see, it says undeclared name f given by the compiler. Even if I try and run this, this will give me the same error where it says f is not defined, because f was only defined for the scope of if block. This will be used when we'll go into understanding maps and other data structures that are there in Go. So there you'll be more relating to this statement where in map, for example, we want to search for particular key. So we'll be using a syntax to search the value, and we can directly access the value and check if that value was existing in the map or not. So that will be there in maps when we discuss about maps. So this statement will be more useful in case of maps or other data structures that we'll be using more advanced data structures with Go. So that's all for if. Now we'll discuss the switch statement as well for now.
Now let's start understanding switch statement. Switch statement is nothing but a replacement of if and else later block. As we've seen in the earlier example where we have compared number A to check if it is greater than 5 or between 3 and 5 or less than 3. So such cases, or in case we have more deeper cases like grading system where we want to compare if marks are greater than 70 or less than 30, uh, similar cases. So in those cases, switch statement is more useful, where your if and else block may get cluttery in the code, or it may uh, be less readable as compared to switch statements. Now, here I've put forward a simple example where I have a name of the user stored in the variable with name, and I want to check what name does it contain. What was the username that is there? So I have written switch, and with switch I have given the variable name for which the value I want to compare. Then case 1, which says if value is equal to Ram, then we'll print user is Ram. Now, one thing that you need to note over here is in other programming language, we use the break keyword. Over here, break keyword is not required. That is added by default when it encounters a next case statement or next default statement or end of the switch statement. Secondly, it also does not have a curly braces to uh, to mark the starting and ending of the case statement. It will automatically analyze that with the same condition that it was using for updating the break statements. In switch, in Go, we do not have fall through. We'll understand that part. So, what is fall through and how it is eliminated in Go. Let's run this example and see what's the output. So it says user is John because the name is John. Now if I change the name to let's say XYZ and now run this, now it says username is not listed because it did not get any of these three statements, these three case statements as true. So it went to the default statement which is equivalent to the else part of the if else later. So we can definitely go ahead and remove this as well. It will print you nothing because we did not give it a default statement. So in if and else, sorry, in switch statement, we were discussing about a fall through condition. In other programming language, you might have seen a case where Let's say I have a number and I have 4 or 5 cases where I can give like this. Sorry, case 2, then again case 4. So this means that we will be saying that any of these 3, 4 numbers are falling in the same code block and should print the same statement. So this is there in other programming languages, but this is not allowed in Go. So to do the same, Go has given us a statement where it says you can combine all these case statements and remove the case keyword again and again by separating all the cases by a comma. So now if I see and run this program, currently my num holds a value of 2. That means it should ideally go and print the case that is there in this case statement. So if I see, it prints even. If I go and give it a value 3, so it should ideally go in the other case. So it says odd. Now if I give it a value of, let's say, 11, which mathematically would be a wrong answer to say, but to demonstrate some default cases, I was mentioning this. It says it is neither even nor odd. Okay. Now, one more thing that you need to note over here is when you are listing the options available, you cannot club or you cannot repeat the options. Let's say I cannot repeat the same values over there in first statement and in second statement again. If I try to run this, it will give me an error saying that duplicate case 8 in switch. So it says the 8 is repeated 2 times in 2 cases. So I can go ahead and remove this. Now in Go, as similar to ifs and else, we can also have a declaration over there in the starting of the switch statement. So if you see, I think F1 is there. Okay. If you see, I have declared a variable with name as num1, which holds a value of 2, and I have passed this num1 to the switch statement. This num1 now will be compared with the value listed over here. Now let's run this and see. It says num1 is even. Now if I try to print num1 over here and num1 over here and then again num1. Now if I try to also access the variable outside the code if switch statement, then let's see if we are able to do it. Now if I run this, it will say num1 is undefined because this was defined in the scope of switch statement. That is why it will not be accessible outside the switch statement. Now if I try to run this program, it will give me even space 2 because we have mentioned to print this value also. Now let's move to another case where in switch we can also use conditional operators as well. So switch in Go also allows us to have conditional operators in the if in the case statement. So I have mentioned 2 examples where I have a variable named A, which is similar to the example that we discussed in the if-else ladder. So here I have variable A and I want to compare if it is greater than 5 or between 3 and 5 or less than 3. So I have used an if-else ladder and I'm converting it to a switch statement as well. So in switch, I have removed the input variable part that was a tag that was supplied to a switch statement. I have removed that completely, and now I am able to give conditions over here where it says b should be greater than or equal to 5. Now the next condition says b should be greater than or equal to 3. Over here, if you see, if a variable value is 6, let's say, it can fall into both the condition, but in switch it will have a default break. So when it meets the first condition as true, it will break the statement and go out of the loop. Now let's try and print this. Now if I see number is less than 3 or number is greater than equal to 5, because b was having 6, which means this condition got true, and over here it is true, so 2, so it means that it went into the else block. Now if I save this as 2, so the output should be same, so the output is same. So now let's move on to one more important aspect of switch statement. In switch statement, you can compare the type of any variable to check what type of variable that is. Now, if I see, I have an example where one second, I'll just comment the old code so that the output does not get mixed up. So over here, if you see, I have declared a variable with name variable. It is of type interface, and this special syntax states that it is an empty interface. An empty interface means it can hold a value of, let's say, integer also, float, string, array, or a structure, or map, anything it can hold. So this variable is as good as an object which can hold any sort of value. And one more important thing about this interface, this is the basic type in which using which every type is actually implemented. So every type can be treated as an empty interface, let's say. So over here, I have declared a variable with as empty interface, and I've assigned a value as 1. Now I want to know in part of my lower part of my code what type of value was this was assigned to variable. What was the variable type? So to do that, we can use the syntax where we have the variable name, then a dot, and in a parenthesis we'll mention the keyword type. So this supplies the type of the variable to the switch statement, and we can use that. Now if I see and print this, it says variable is of type integer. Now if I convert this to point 2, it should be float 64, so it should go into float 64 block. Now I can also try and repeat this for float 32. It should not go into float 32 block. So it went to 64 only. Now I can also declare this as an array which holds two values of type string, and let's say, let me run this program. I, I missed this curly bracket over here. Now let's run this. It says variable is of type string array of size 2. Now if I declare this with three variables, now if I try to run this, this is uh, this will not end up in getting into this, because this case is specific to type. We have specified type of uh, array, or we have specified the size of array over here. So in that case, we need to specify the length also same, and then only it will give me the appropriate result. So any array of type which has a value containing value 3 or an same array, another array which has value that are stored as two values stored. So those two arrays are of different types because the first one contains three values whereas second one contains two values. No matter what is the individual value type, but the arrays are actually different. So that is why we need to take special care when we uh, write any cases for the type of arrays. So that's all for the switch. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.